Hello there, just a quick video on finding the volume of a triangular prism. Now in this part 1, I'm just interested in triangular prisms where the face is a right angled triangle. In other words, see that there? That's what I'm calling the face, where the face is a right angled triangle. You can see the right angle right there. So really how we do it is this: we find the area of the triangular face, and we simply times it by how far that face goes back. And I hope you can see that it goes back 1.8 metres. So once we found the area of this triangle, we simply times it by 1.8. Now you may have seen this formula here: volume equals area times h. Now the area is standing for the big A there, the area of the triangular face. Okay, so we need to find that. So we find A equals, now the triangular face, well, it's a triangle, so we need the formula for the area of a triangle, and that is base times height divided by 2. Okay, there are other ways of writing that. Commonly it's seen as this: half base height, or sometimes equal written like this: base times height divided by 2, because a fraction is a division. Anyway, whatever we use, we can say in this case the area of this triangular face here is half the base times the height, or base times height divided by 2. Okay, so let's go base, well that's 4.2, times 0.6 is the height, 0.6 is the height, divided by 2. Just squeezed it in. So if we now go to our calculator, we'll find that the area is 4.2 times 0.6 divided by 2 is 1.26. Now that's an area, so it's metres squared. Okay, we don't strictly speaking need the units there because this is just working out. Now remember, that's the area of the triangular face, okay? The area of that triangle there. What we want is the volume of the prism. So we simply times the area by what's called the height, which is a bit misleading. It's how far the face goes back, so it's 1.8 metres. Okay, so we can now say that therefore the volume equals, what was our area? 1.26 times the height is 1.8, and on our calculator we will discover that that is equal to therefore volume equals 2.268. Let's not forget our units, which are metres, and this is volume, so it's cubed. 3D space, we're going to use cubed. Now in this one, I'm going to start it for you, but I'd like you to finish it off, and I will give you the answer. But you'll see that the problem here is that the height of the triangle is unfortunately in millimetres. See that? Whereas the length of, let's call it a ramp, that's in metres. Okay? The width of the ramp is in metres as well, so that's good. But we need to either get the metres converted to millimetres or the millimetres converted to metres. I think what I'd prefer to do is convert the millimetres to metres. Now what we do is to convert millimetres to metres. Firstly, we would divide by 10 to convert the 180 millimetres into centimetres. So 180 millimetres would equal 18 centimetres. And then if you can hold that in your head, what we do is we divide the centimetres by 100. So we move the decimal place 2 places that way to convert it to metres. In other words, the 180 millimetres will equal 0.18 metre. So now what we have is the units all the same. We've got metres there, there and there. Okay, so why don't you press pause now and see if you can find the volume of this triangular prism, and I will show you the answer when you press play again. Okay, I don't know how you went on, but that's the working there for you to follow. Okay, so the answer is the volume equals 0.648 cubic metres. Well, you might have noticed in the previous examples I had little thetas in the triangular faces, and that's because I might want to find the angle of elevation of, let's say this is a ramp, okay? So that theta there, it's a Greek letter theta, that's how we pronounce it, theta. I'll just enlarge it so it's clearer. Theta looks like that, or even better, like that. Oh dear, it's a bit wonky. Anyway, it doesn't matter. We want to find that angle there. So we're going to need trigonometry. And what we're going to have to remember is good old ka tawa. So ka tawa. Sorry, my stylus is a bit hard to move. Okay, so what we do is we focus on that angle and we ask ourselves this question. In relation to that angle, what side is that? Is it opposite, hypotenuse, or adjacent? Well, it's opposite, isn't it? The side marked 0.6 is opposite that angle. The hypotenuse, by the way, is always opposite the right angle. So, but what about the 4.2? That's adjacent, isn't it? Well, if it can't be opposite and it can't be hypotenuse, it must be adjacent. So we're going to need the trigonometric ratio that has opposite and adjacent in it. Look at the ratios again. So, ka tawa. Clearly it's that one there, isn't it? It's the tangent ratio we need. So what we say is that tan theta equals the opposite side, which is 0.6 over 4.2. And then we go to our calculator, no need to simplify that at all, and we press this, shift, I'll write it in for you, shift, and then press tan, and brackets should open up. If they don't, you'll need them, so put in brackets if they don't appear on your calculator. 0.6 divided by, because a fraction, remember, is a division, divided by 4.2, and out will come your answer. Okay, so when you do that, let me just do it. We've got shift, tan, and on my calculator brackets already open up, but I will probably need to close them. 4.2, close the bracket, equals, and I've got an angle there of 8.13 degrees. Okay, very good. Now on the next page, I'd like you to try the other one. So press pause and I'll show the answer after you press play again. Okay, so clearly this is an angle of elevation problem, so we are interested in the ratio that fits that side and that side. Well, they're the same as in the previous example on our right angled triangle, so we're going to need the tan ratio again, the tawa. So we just say, tan theta, the tangent of that angle is equal to the opposite side, which is 0.18, over the adjacent side. And we go to our calculator again. And remember what you press shift, tan, 0.18 divided by 3.6, close your brackets, and that equals 2.86 degrees. And by the way, that has been rounded, so you should say how much you're rounding it by. That's to 2 decimal places. Okay, so that's an angle of elevation problem that might apply to something like a ramp in this case. That's all for now. See ya.